Since yesterday we have been looking at the basic principles of dyeing, and then further on we tried to understand the role of mordant, how these mordants, metal salts, particularly the aluminum and the ferrous ions which are trivalent, coordinate with the oxygens of the dye molecule belonging to the hydroxyl group, and this coordination helps them to adhere to the fabric. Now, all this we have learned, and we also learned that for dyeing cotton, which does not support or does not have too many free hydroxyl group on the surface, needs to be treated with tannic acid, so that the surface of the cotton then develops adhering groups, and therefore, the dye and the mordant and the tannic acid and the fabric, they all come together to actually be a part of the dyeing process. Now, let us try to see today a typical dyeing process for cotton, because it is important for you to know what are the basics of natural dyeing, what are the requirements of natural dyeing. Dyeing procedure for cotton as well as silk has little variation, but nevertheless we will go through the entire process in order to understand what are the requirements that one must be ready when one is doing natural dyeing. One should be ready with the natural dye, either a fresh extract or a powdered standardized natural dye. Then one must be ready with alum or ferrous sulphate, stannous chloride, whichever is the mordant that one needs to use. One thing I have all along told, that the water should be soft water. Hardness should not be more than 300 ppm, which means that the interferences caused by the calcium and the magnesium ions should be avoided. Dye pot, it should be made out of stainless steel or glass or porcelain. Why? Because we saw that in the examples where tin pot or aluminum pot or iron pots were taken, the dye extract showed a difference in the hue color. That was because the metal was leaching in at that pH, and the dye was not just the dye solution, it had the metal component also. So, it was like simultaneous mordanting was occurring. So, therefore, it is important to only use stainless steel or glass or porcelain. And the temperature indicator, that means there should be a thermometer, one should keep a track of what is the temperature of the dye bath, and of course, the heating medium. One cannot heat it too high or too low, otherwise the dye uptake will not be optimum. So, these things have to be kept in mind while one is using natural dye. So, natural dye, mordant, soft water quality, dye bath should be made out of a material which does not leach any metal ion, and temperature device and heating device. Now, how do we prepare a ready to dye fabric or textile material? There is a particular protocol that needs to be followed, or a methodology that needs to be followed. You can apply your own process. It is advisable that the material should be at least semi half bleached. That means, it should not be a grey material, but it should be bleached material, and one can then start doing the scouring, or bleaching itself will take care of the scouring process. Then comes the pre-mordanting. Yesterday we learned that there are 3 processes. We can either treat the mordant in before dyeing, or we can put the mordant after dyeing, Or the third option is that we can put the mordant and the dye together, that is called simultaneous dyeing. So, or simultaneous mordanting. So, in the case of pre-mordanting, if that is what is required, add required quantity of required mordant. Mordant should not be more than 2 to 4% of the weight of the fabric. In lukewarm water, stir well and filter it, so that there are no lumps of this mordant salt. Now, what happens? I will give you practical tips, because usually if it is not stirred, if it is not mixed uniformly, if it is not filtered for the lumps that are still remaining undissolved, what will happen? That the fabric will have these lumps sitting on it, and eventually on those positions the dye uptake will be very abnormal. And if the dye uptake is abnormal, it goes to prove that the dyeing will not be even, and it will create patchiness. Raise the temperature of the solution to 80 degrees. Immerse the textile RFD, that is ready for dyeing material, in the solution stirrer. Stir the same, so that material should be in movement for 20 to 25 minutes. Drain the liquor and slightly squeeze the mordanted material, but do not wash, because if you wash, the entire mordant will run off in the water. So, what one does? One just dips it in the mordanted bath and takes it out, slowly squeeze it and just dry it. After mordanting textile material, and proceed for the next mordanting or dyeing as per the recipe. Now, if this mordanting or pre-treatment, as in the case of cotton, in the case of cotton one requires tannic acid pre-treatment, then mordanting if one is using pre-mordanting, and then dyeing. So, that is the sequence, but that is not the case in all the cases. In some cases, like in silk, we do not need the pre-treatment procedure of tannic acid for silks, because silks have amino acids or proteins, and these proteinaceous materials have amino group and carboxylic group, which are good adhering group for the dye. So, therefore, the procedures are slightly different. Now, add the required, when we start doing dyeing of cotton, add the required quantity of dye in lukewarm water, stir well and filter. If simultaneous mordanting is required, add the required quantity of mordant and the dye in the same dye bath before immersing the material in it. So, as we all know that in the case of simultaneous mordanting, after the pre-treatment of the tannic acid, directly we go to the dyeing process, and in the dye bath itself the mordant is added, but the same required amount 2 to 4% of the weight of the fabric. Then slowly the temperature is raised to 80 degrees. Immerse the above mordanted textile material in the dye bath for 30 to 35 minutes or even sometimes for 1 hour. During the entire course of dyeing, the material should be in movement. So, it should be stirred. Yesterday also we were talking, when we were looking at the basic concepts and basic principle of dyeing, that the dye solution and the fabric should not be left still. Why? Because what happens is that at that particular point the dye uptake will be much higher, and therefore, it will, and other places which are not exposed to the dye solution or fabric portion, if they rise from the surface of the dye solution, will remain undyed. So, this is not a very good situation and would cause patchiness. Another thing that one has to keep in mind is that dyeing must be done in a very even manner. Unless and until one gets an even dyeing, it is not considered to be a good dyeing process. Therefore, the movement is very important, and because Even when I will be talking about the jigger and the winch, these are big dyeing machines, you will see that the fabric is a constant touch with the dye solution and is in movement. So that at a time too much of dye solution is not in contact with the fabric, and that is what the whole idea is. Actually, the dye is taken up by the fabric through the pores of the knitted fabric, and this capillary action is more facile when the dye solution is momentarily in contact with the solution. Otherwise, the process will take place, go on taking place, and there will be a dye aggregate in one place and other will remain undyed. So, this will cause patchiness. So, that is why it is important to understand what is the role of stirring the dyed material, or what is the emphasis, why is it emphasized that all the time the movement should be there, or stirring should be there, or fabric should not be kept still in the dye bath. Post-mordanting, as I said, either the dye either the mordanting step can be carried out before dyeing, which will be pre-mordanting, or sometimes in order to get some beautiful or some different shade, the practitioners, natural dye practitioners, try to do post-mordanting. Drain the liquor and slightly squeeze the dyed material, but do not wash. Add required quantity of required mordant in lukewarm water, stir well, filter it and add to dye bath. Raise the temperature to the solution of the solution to 80 degrees. Immerse the dyed textile material in the solution and stir the same so that the material should be in movement for 20 to 25 minutes. In case of using ferrous sulphate as post-mordant, the mordanting should be conducted at ambient temperature, because as it is, the ferrous salt is very it brings in darker shades, and it is not necessary to heat the iron salt so much. Therefore, it can be carried out at room temperature, but other post-mordanting processes must be carried out at 80 degrees, and that is the most ideal temperature, because it is slightly below the water boiling point and it does the needful. But whether we do pre-mordanting, whether we do post-mordanting, or whether we do simultaneous mordanting, the role of mordanting is very, very important, especially when we are dealing with natural dyes. Post-treatment, sometimes it is also necessary to do post-treatment of the fabric. Drain the liquor and slightly squeeze the dyed material. Wash the dyed material with plain water. Wash the dyed material with 0.5 GPL non-ionic detergent at 60 degrees. Again drain the liquor and slightly squeeze and wash the dyed material with plain water until the detergent rinses out. Treat the material with your own method of fixing agent and softener as required. So, many a times dye fixers have to be used. Now, what happens is that there is some loose dye molecule on the surface that needs to be rinsed out. So, the first time it has to be rinsed out with a mild detergent, but nevertheless a dye fixer always assures that whatever has adhered to the fabric will remain on the fabric, and therefore, treatment with dye fixer is always advantageous. There are commercial samples of dye fixers which are being marketed by BASF and Ciba Geigy and so on, and these are nothing but softeners. They try to act like a coating, an invisible coating on the fabric, so that the color does not run off. Now, if one tries to look at a simple recipe, what would be the kind of recipe if one desires to have a light yellow shade? the vegetable dye that should be used is Tectona leaves 8% with 1.5% of copper sulphate as the mordant. So, you see that this recipe is just like our cookery recipe, that the formulations are given. How much of the weight of the fabric should the dye powder be used? 8%, and the copper sulphate should be very little in quantity and minimum requirement is 1.5%, that would yield a yellow color on the fabric, cotton fabric. If a medium yellow is to be obtained, another dye can be used, a dye from the Punica granatum or Anarka chilca 8% with the same copper sulphate as 1.5 mordant. If dark mustard yellow has to be obtained, then the alum should be used as a pre-mordant and the dye that should be used is 5% punica. Alum and punica not as simultaneous dyeing, but as pre-mordanting will yield dark mustard yellow color. If light pink has to be obtained, a simultaneous dyeing of Terminalia arjuna bark 5% powder with 1% copper sulphate should be used. If brown pinkish has to be obtained on the cotton fabric, the combination of dye and mordant should be that simultaneously catechu 5% powder and copper sulphate 1% powder. If maroon color has to be obtained, a cationic fixer must be added and potassium alum 8% with lac dye 8% should yield the maroon color out of the lac dye. Normally, lac dye would yield a color which would be ranging from red to purple, and by the time it is fixed and mordanted, it sometimes has a very different kind of a shade. But if one wants to keep the reddish maroon color intact, then cationic fixers must be added, so that it takes care of the pH. If you recall, lac dye was a lactic acid, most of them were acidic material, and therefore, it is important to add a cationic fixer, so that the pH is maintained and all the acid groups are more acidic in nature and would provide the reddish maroon color. If light brown has to be obtained, a pre-mordanting with ferrous sulphate 2% and Terminalia arjuna 7% would provide light brown color. Now, you will see one thing, that the recipe shows pre-mordanting, the recipe shows that simultaneous mordanting, but all along you will see that copper sulphate, wherever it has been used in bare minimum quantity, that is ranging from 1 to 1.5% only, and the dye could be from 5 to 8%. So, as a basic rule, the dye, powder or extract, whichever you are using, must be having a 5 to 8% of the weight of the fabric, whereas the mordant can range from 1 to 2%, preferably when we are using copper or chromium mordants, but in the case of ferrous or alum, it can go as high as 4 to 8%. So, considering the toxicity of copper and chromium, one has to keep the mordant level low. Now, when we try to look at the dyeing procedure for silk, there are small amendments here as well. You will see that whatever natural dye is being used, like you can take natural dye which is catechu, which is from the flower extract or from any source. Mordants the same alum, ferrous sulphate, stannous chloride. Here also the soft water should be used, hardness should be still lower, that is less than 50 ppm, and the dye bath should be made out of stainless steel, glass or porcelain. One should have a thermometer to keep a check of the temperature, and there should be a heating device or a heating medium. Now, how do we prepare a ready for dyeing material when it comes to silk? One should use a bleached or a semi bleached silk, and if pre-mordanting is required, then add required quantity of the required mordant in lukewarm water, stir and filter. The same practice has to be carried out. Raise the temperature of the solution, that is the mordant solution, to 80 degrees. Immerse the textile which is ready for dyeing in the material, that is RFD is the short term, in the solution, and stir the same so that the material should be in movement and there is even coating of the mordant. Drain the liquor and slightly squeeze the mordanted material, but do not wash. I told you why washing is prohibited here, because it should not run off the mordant. After mordanted textile material, and proceed from further mordanting if required or directly to dyeing. Now, when we try to do dyeing, there are of course 3 different ways of dyeing. One is using a pre-mordanted fabric and then dyeing, or we can have a simultaneous mordanting and dyeing, or we can have first dyeing and then mordanting. So, whichever is required or whichever is the choice for that particular type of exercise, one can go for simultaneous mordanting if required, add the required quantity of mordant and dye in the same dye bath before immersing it in the material into it. Raise the temperature to 80 degrees and maintain the pH of the bath between 3 to 3.5 by acetic acid if required. Now, you see that this particular step was not there in cotton dyeing. This is particularly a typical case where we are doing silk dyeing. Immerse the above mordanted textile material in the dye bath for 30 to 35 minutes. During the entire course, the dyeing material should be in movement. Here also, in order to have evenness, in order to avoid patchiness, one needs to have a constant movement of the fabric while dyeing. Post mordanting, wherever it is required, drain the liquor and slightly squeeze the dyed material, but do not wash. Add required quantity of required mordant in the lukewarm water, stir well, filter it and add to the dye bath. Why I am all the time emphasizing that even the mordanted solution should be stirred well, should be filtered, because again and again any kind of lump, undissolved mordant salt can create patchiness on the fabric if it adheres to the fabric. Raise the temperature of the solution to 80 degrees, immerse the dyed textile material in the solution and stir the same so that material should be in movement for 20 to 25 minutes is generally sufficient, but sometimes if the required shade is not obtained, one can prolong the heating up to 1 hour. In case of using ferrous sulphate as post mordant, the mordanting should be conducted at ambient temperature. This is the same, because ferrous does not require any further heating, only at room temperature this can be carried out very easily. Now, post treatment is common to both the cotton and silk. Drain the liquor and slightly squeeze the dyed material. Wash the dyed material with plain water, then wash the dyed material with 0.5 GPL non-ionic detergent at 60 degrees. See, these procedures are important in order to understand that any surface adhering extra dye must be washed off, otherwise it will cause bleeding to the other fabric which are washed together. Again drain the liquor and slightly squeeze and wash the dyed material with plain water until the detergent rinses out. Treat the material with your own method of dye fixing or softener as required. Now, one thing that has to be kept in mind, all the given percentages of mordant and dyes in the recipe are OWF on the weight of the fabric. So, it depends on what is the weight of the fabric. It is not a measurement just like that in the volume of water. It is with respect to fabric, because the fabric is the one which will take up the dye. So, therefore, it is always referred as OWF, that is on the weight of the fabric. Material should be in wet position before immersing the dye bath. Now, there are little tips that needs to be brushed up, because you see dyeing is an art, and in this art if one masters over these little nuances, then one can actually do perfect natural dyeing. Of course, one learns through practice, but if slightly wet cloth is immersed as compared to completely dry cloth, what will happen that in the wetted cloth the capillary action is enhanced, whereas in dry cloth the capillary action is slightly retarded. Now, through the capillary action the dye molecules actually get into the meshwork of the fabric. So, that is facilitated if the initial dyeing material is slightly wetted. If it is not wetted, if one does it, of course, the dyeing will take place, but the movement or the capillary movement of the dye molecules will be slightly retarded, will be slightly uneven, but in the case of wetted cloth it is very even. So, now the choice is yours. You know that this facilitates and the other one retards. So, would not you choose to opt for a procedure which facilitates the process, which makes it more even, which makes it more proper, rather than going for an improper process. Now, similarly, we have developed some recipes for silk dyeing. Now, if one wants to get yellow dye, yellow shade on the fabric, potash alum 6% and punica, that is anarka chilka 5% is just the best combination. If one wants to get orangish yellow, rubia cordifolia dye powder 5% and potash alum 5%, even simultaneous mordanting would be very helpful. Similarly, if one wants to get olive green with punica, potash alum and ferrous sulphate 1%, one can get 6:5:1 ratio of the punica, alum and ferrous sulphate can give olive green shade. Pinkish red if one wants to obtain on silk, lac 4% and stannous chloride 2%. If one wants to get maroon color from lac dye percentage should be increased to 6%, oxalic acid 6% and stannous chloride 2%. So, you see that whenever we are using alum, we are going up to 5%, but ferrous sulphate, stannous chloride are all between 1 to 2%. If light purple color has to be obtained, lac has to be taken as 4%, potash alum as 1% and 3% citric acid. This will give light purplish shade. Similarly, if dark purple color has to be obtained, potash alum 5%, tartaric acid 2.5% and lac dye 3% has to be used. If violet has to be obtained, lac dye 4%, potash alum 2%, ferrous sulphate only 0.6% is required, which will give the desired color. If light gray has to be used or if light gray color has to be obtained on the silk fabric, lac with tannic acid 2% and ferrous sulphate 2% gives the required blackish gray color. The gray color can also be obtained on silk from Terminalia arjuna 4% and ferrous sulphate 2%. Light brown can be obtained with Terminalia arjuna 5% and copper sulphate 2%. Bronze color can be obtained from catechu 3% and copper sulphate 1.5%. Similarly, reddish black can be obtained from lac 4% and ferrous sulphate 2%. So, you see different combinations of the dye powder or fresh extract with different concentrations of the mordant ranging from potash to ferrous to copper can give various color combinations in this on the silk fabric. But one thing that you have to remember, when to add what to get what color, and these recipes are just a directive that this is what you will achieve if this is the kind of combination that you use. Of course, you can have your own combination system and you can develop many colors out of combination of dyes. With natural dyes, there is also another advantageous situation that one can use two different dyes one by one or simultaneously and get a completely new shade. One can use different mordants, either use post-mordant, either use pre-mordant or post-mordant or simultaneous mordant and get different shades. So, from the same dye extract, the color variation can be immense. By changing the mordant, even then the color shade differs. It is not that you will get the same color with all the mordants, and that is the beauty of natural dyes, that from the same dye extract one can get different shades, completely different shades, reddish to green from the same dye. From anthraquinone dyes or anthocyanin dyes, this is possible just by manipulating the pH or by manipulating the mordants, and therefore, one can have a whole large range of coloration on fabric, be it cotton, be it wool or be it silk. Now, these are some of the steps of dyeing which I have just shown here, just to give you an example how this vessel, which is an open vessel, can be utilized and dyeing can be carried out very efficiently using gloves and using these kind of open troughs which is directly kept on the gas, and beautiful tie and dye fabric can be seen, which is shown in the last slide. Now, one can use materials from root, barks and woody material. Most wood products release best color when soaked in water or overnight. While there are few exceptions, most woods do not yield good color when boiled directly. Soak wood, bark or roots for 30 minutes before boiling is recommended. If the dye liqueur still looks weak, simmer longer up to 3 hours. So, if the wood is soaked overnight, that is the best. Many woody material will not yield a significant dye color unless a modifier is added. Experimentation is required here. In a small container, place a small amount of dye liqueur, mixing different mordants and auxiliary, and that will yield different colors. Some woody products yield colors only under basic conditions. Adding soda ash and or baking soda will extract the desired color. So, these are various methods of getting the dye out from the wood or bark or woody material. wood sizes sawdust works best, but not every piece of wood you collect will be can be formed in the sawdust. Of course, the bigger the surface, the better will be the effectivity, but nevertheless, the smaller the piece is, the better the dye extraction will be. Use of wood leaf chipper of the garden variety to chip the wood up and then allow it to soak for several hours is the ideal situation. Straining off the chips, placing the dye liquor into bucket and grinding the chip in food grinder or processor is also possible. Then placing the chip into the original dye bath, often or more liquid gives you more color. So, the larger the surface, the better it is. Similarly, for flowers are a bit easier than woody material. Soak the flowers overnight before heating up the dye liquor. Sometimes freezing the flowers before boiling liberates the color very easily. Otherwise, bringing the dye bath up to a simmer to 40 to 70 degrees, where it remains for 30 minutes. So, there are various ways, either it can be left for overnight or it can be just frozen and then put into boiling water, and that would help to actually get the dye out of the material. And dye from the fruits and vegetables, using the same method with fruits and vegetable as the flowers. However, it may run through a fruit grinder processor first to ensure the greatest amount of color extraction. Following are the basic recipes that are recommended often for dye fabrics. So, you see, for a Genda flower, which is a very common flower tegatus, there is the flower can be simply taken and put into a plastic bucket with hot and not boiling water. That itself will extract most of the color. So, from plant to plant, if suppose even if we do not have a Soxhlet extractor, if we do not have an access to the supercritical extraction process, if we do not have a sonicator in our hand, simple experiments can also help in extraction of the dye. Simply by taking a 5-liter bucket or container will work, and Marigold yields greatest color if allowed to soak for 6 to 10 hours. Just place the solution in warm area or in a heated kind of room, and just place it in the warm place for overnight. Overnight soaking itself will actually bring out all the color, and then simply filter the Marigold liquor into the dye bath and evaporate the dye bath, whereas all the biotic material can be easily used for composting. So, there are simpler methods also for extraction. It is not that for a dye procedure, for doing natural dyeing, you have to have a very elaborate laboratory to do that. Things can be done even in the house in simplified manner, and of course, things can be carried out in a very exclusively designed laboratories.